Hi, everybody. We're going to do a quick lesson on chemical reactions and balancing them. We're going to learn a little bit of vocabulary associated with it, why we have to do it, how to do it, and definitely probably the most important thing that we're going to do is what are some strategies that are going to help you to be successful when you are balancing chemical equations. Now, as far as the why, I think you probably remember the law of conservation of matter from earlier in the year, where it said that the substances before the reaction have to be equal to the substances after. Specifically, the mass, our total mass before the reaction has to be equal to the mass after the reaction. Because in a chemical change, matter is not created or destroyed. So if we have one carbon before the reaction, we need to have one carbon after the reaction. If we have 4 atoms of hydrogen before the reaction, we need to have 4 atoms of hydrogen after the reaction. And we can see that here, we only have 2 atoms of hydrogen in this water. So that's why we are going to have to balance this chemical equation, because right now it is what we would call unbalanced. The number of hydrogen atoms on each side of this arrow, which separates the before and the after, is not the same. The oxygen isn't the same either, because before the reaction we have 2, and after you can see we have 2 oxygens in the carbon dioxide, and we have 1 in the water. So we have 2 oxygens over here, and we have 3 after the reaction. So we have a lot of things here that are not balanced, which means that right now, the way it stands, the law of conservation of matter would not be being satisfied because we don't have the same thing before and after the reaction. You always get different substances after the chemical reaction. Remember, a chemical change is where a new substance is made. But those new substances are just made by breaking bonds, like we're going to break the bond between the carbon and hydrogen. And then carbon's going to join up with some oxygen, and the hydrogen's going to join up with some oxygen. So, we're not talking about the exact same substances, but we're talking about the number and type of atoms before and after the reaction has to be the same. A little bit of vocab. The reactants are the substances that are present before the reaction. In this one, it would be the methane, CH4, and the oxygen gas, the O2. The products are the substances that are present after a chemical reaction. In this particular case, it would be carbon dioxide and water. So we need to balance this and get the same number of carbons on both sides, hydrogens on both sides, and oxygens on both sides. So one of the rules is that we can never change any of the subscripts to balance a chemical equation. We might say, for example, okay, we need 4 hydrogens. So instead of a 2, let's just put a 4 in here. Well, the problem there is that H4O, that's not the formula for water. And this reaction makes water, and we have to keep the formula for water. We cannot change that, okay? The only thing we can do is we can add coefficients, which are in front of the formulas, to get the equation balanced. So for example, if we need 4 hydrogens over here on the right, the thing to do is to have 2 separate water molecules. If I have 2 molecules of water, and I'm trying to draw one here, there's one, and then I have another one, then you can see that with 2 separate molecules of water, I actually have 4 atoms of hydrogen. When you put a coefficient in front, you're actually multiplying that number by each one of the subscripts. Like here, we have 4 hydrogens and 2 oxygens by having 2 molecules of water. Does that make sense? So that coefficient that's in the front actually multiplies by those subscripts to tell you how many of each element are on that side of the equation. So you multiply the coefficient by every subscript. So this represents 4 hydrogens and 2 oxygens. So now that's balanced because we have 1 carbon on each side and we have 4 hydrogens on each side. But we've got to check our oxygen. Right here, let me switch colors for the oxygen, just to help keep it straight. Right here, we've got 2 oxygens, okay? Over here in the water, we also have 2 oxygens. It's 1, but then with the coefficient of 2, we have to multiply that. So we have 2 oxygens here, and we have 2 oxygens here. That's a total of 4 oxygens after the arrow. Now over here, I can't change this to a 4. Remember, you cannot change the subscripts. But what I can do is get 2 different molecules of oxygen. Remember, a molecule of oxygen looks something like this. It's a double bond between the O's. So if I get 2 of those, that's going to give me a total of 4 oxygen. Oops, I changed to the eraser. That's going to give me a total of 4 oxygen atoms. So now I would actually have a balanced equation where basically these coefficients are telling us that 1 molecule of methane reacts with 2 molecules of oxygen to give us 1 molecule of carbon dioxide and 2 molecules of water. These numbers, these coefficients, should always be the lowest ratio. I don't want to put in this like 2, 4, 2, 4. Yeah, that would be balanced, but we should always keep it as simple or simplified as possible. And they represent for us a ratio. Like for every 1 molecule of methane, I need 2 molecules of oxygen. I will get, after the reaction, 1 molecule of carbon dioxide for every 2 molecules of water. Okay? These numbers are going to be important for some of the work that we do later with ratios of reactants and products in chemical reactions. So the thing that I really wanted to go over with you today was just some of the strategies for balancing reactions. So one of the strategies, which, by the way, I should say before I say that it truly is trial and error. You just have to play around with the coefficients and do some counting on each side to get these to balance. But there are some strategies that can make it easier. So I thought I would go over a couple of reactions and show you those strategies. One of the things I would do is leave the elements that are by themselves, like in this case, the silver, just leave it till last. Now it's pretty easy to see in this one anyway, but like if you have an element that's by itself, you can put any number you want in front of there and not mess anything else up. So just do it last. So I'm going to do the oxygen first in this case. Okay, before the arrow, I have 2 atoms of oxygen. Over here, remember, that's only a 1. So if I want 2, I need to put a coefficient of 2 to double everything. Now I've got 2 oxygen on each side, but 2 times 2, I have right here now 4 silver, and I can come back and put that 4 in there, and I have it balanced with the coefficients of 4, 1, 2. And I say 1, there's nothing written there, but remember, just like no subscript is assumed to be 1, no coefficient is assumed to be 1 as well. Okay? And it's actually proper just to leave it blank and then it be assumed that it is, that it is a 1. All right, so let's try another one. We've got more elements here. We've got lithium, bromine, and oxygen. Okay. And another strategy is that sometimes we like to use what's called the least common multiple. Okay. So for example, if I look at this, the lithium is balanced, the bromine is balanced, but the oxygen, I have 3 on this side and 2 on this side. So I'd say to myself, what's the least common multiple of 3 and 2? It's 6. So to have 6 oxygen on the right, I need to take a coefficient of 3 times a subscript of 2, and that gives me 6 oxygen over here on the right. To have 6 oxygen on the left, I need a coefficient of 2 to multiply by the subscript of 3, and that gives me 6 oxygen on the left. Now, this 2 in front also doubled the lithium and the bromine. So now I have 2 lithium and 2 bromine. I got to go back and fix those. I put a 2 here, and that'll give me 2 lithium and 2 bromine. Okay, so we've got 2 strategies. If an element's by itself, do it last. And sometimes you want to use the least common multiple to get you started. All right, 2 other strategies that I like to use. Whoa, now there's a lot of elements, okay? There's magnesium, there's oxygen, there's hydrogen, there's phosphorus. First of all, let's go through this and make sure we know what these formulas mean. Like right here, this is 1 magnesium. The 2 applies to doubling everything inside of the parentheses. So this is 2 oxygen, 2 hydrogen. Right here in the phosphoric acid, we have 3 hydrogens, 1 phosphorus, and 4 oxygen. There's no parentheses anywhere, so that 4 only goes with the oxygen. Here's magnesium phosphate. We have 3 magnesium. And you see this 2 outside of the parentheses? That means you double everything inside of the parentheses. So this is 2 phosphorus and 8 oxygen. And then with water, we have 2 hydrogen for every 1 oxygen. So when you have a parentheses, that means that you need to distribute or double. Like here, if this was a 5 outside, we'd have 5 phosphorus and 20 oxygen. So you're kind of multiplying that number through. You got to distribute it through. So when there's a lot of elements, I have found that one of the most useful strategies is to do things in this order. Do your metals, to the non-metals, then the hydrogen, and then balance the oxygen last. See, there's oxygen in all 4 of these substances. If you start trying to fool with numbers to balance the oxygen, you're going to constantly be messing something else up. But you watch, if we do this order, metal, non-metal, hydrogen, oxygen, a lot of times by the time we get to the oxygen, it's balanced, or there's only one thing to adjust. So let's do this. So magnesium is the metal. On the right side over here, we had 3. So on the left side, I'm going to put a 3 because we only have 1 magnesium. So we got to triple it to get 3. Now the magnesium's done. Okay. So the metal is done. All right. Now the non-metal. The non-metal is phosphorus. Remember here, we have to multiply. So this is like 2 phosphorus over here. 2 times, the one that is inside of the, like this is a 1 right here, times 2. So we have 2 phosphorus. So we got to come over here and put a 2 in front of the phosphoric acid to double the phosphorus. So now the phosphorus is done. The non-metal is done. Sometimes you might have more than 1 non-metal, like you might have some phosphorus and some carbon or something. You got to do them all. Now we'll look at the hydrogen. We have hydrogen in 2 places on the left side. Right here, okay, we have 2 times the H right here times the 3. So we have 6 hydrogens from that magnesium hydroxide. And then the phosphoric acid, 2 times 3, we have 6 hydrogens right here. We add those. See, look, this is added, right? See that plus sign in there? So we need to add those together, okay? Let me get some of this other stuff out of the way. Oops, I accidentally erased my 2. Darn it. We'll put that back in. There we go. Okay, so we need to add these. We have a total of 12 hydrogens. So we come over here on the right, and we can see that, I'm trying to erase the phosphorus. There we go. We come over here on the right, and we can see that there's no hydrogen anywhere in here. And right here, there's 2, but we need 12. So what number times 2 is going to give us 12? We would need 6 molecules of water to have 12 hydrogen. So by putting a 6 in front of there, now the hydrogen's balanced. And then we need to balance the oxygen. Okay, I just need to erase these hydrogen numbers. So in balancing the oxygen, here again we have 2, see this 2, times the 3, so we have 6 oxygen up here. And we have 2 times 4, we have 8 oxygen right here. So this is a total of 14 oxygen on the left. That means I need 14 oxygen on the right. Well, here I have 2 times 4, so that's 8 oxygen. 1 times 6, that's 6 oxygen. 8 and 6, I got 14 oxygen on the right as well. So you see, by the time we got to the oxygen, it was already balanced with 14 on each side. And we did that just by balancing the metal, the non-metal, and then the hydrogen. So if we have 14 oxygen on each side, they're balanced, and this equation is done with the coefficients of 3, 2, 1, 6. And that cannot be simplified at all, so we know we have it. This will be the last one that we would do. Okay, let me get a different color just to mix it up. All right, so metal, there are no metals. So then I'm going to try and do the non-metal. So right here I have 4 carbons. So I'm going to put a 4 here. Then it says to do hydrogen next. So hydrogen, I have 10. So 5 times 2, that's going to give me 10. All right, so we've done non-metal, the hydrogen. Now we have oxygen. Over here, we have 8 oxygen. Here, we have 5 oxygen. So we have 13 oxygen. There is no whole number that we could put in there and multiply by 2 and get 13, because 13 is an odd number. Does everybody see that? We're kind of at a standstill because we've got these 13 oxygen over here on the right, and we have no way of getting 13 over here on the left. So what are we going to do? Well, the strategy is if everything but one element is balanced, like everything is balanced here except oxygen, okay? And you have odd on one side and you have even on the other, which that's the case, right? Just double all your existing coefficients. So like here, right here, instead of a 1, I'm going to make this 2. And then over here, the 4 has to become an 8. And the 5 has to become 10. Wow, our numbers are getting big now. Because here, 8 times 2, here we have 16 oxygen. 10 times 1, and we have 10 oxygen. We now have 26 oxygen. That makes sense because we had 13 before and we doubled it, so now we have 26. I can put over here a 13 because 13 times the 2 will give me 26 oxygen. And so I have 26 on each side. So now my carbons are equal, 8 on each side. My hydrogens are equal, 20 on each side. And my oxygens are equal, 26 on each side. So we've got a little bit of vocabulary, like coefficient is the number in front of the formula. Subscripts are the little numbers that are within the formula that tell you which atoms are bonded together to make the molecule. We've got reactants, which are before the arrow. We've got products, which are after the arrow. We know we balance the chemical equations because of the law of conservation of matter. Okay. We add the coefficients in the front and we keep track of each element on the left and each element on the right, and we adjust those coefficients until every element has exactly the same number on the left and on the right of the arrow. A couple of strategies to help you out, but honestly, it's going to come down to trial and error and you adjusting numbers until you get it to work out. So I've got a website that I'm going to direct you to for practice. Okay, I think it's very important. You can set it on this website to easy, medium, and then I don't know if they call it hard or challenging. But when it's easy, they will give you some of the coefficients and you just practice adjusting one of them. And then as it gets harder, they're giving you less coefficients and you're practicing adjusting all of them. Once you have played around with that website a little bit, then there's an Edpuzzle for you to do. And tomorrow we will work on doing some more balancing of chemical equations, because this skill is really crucial. It's going to affect a lot of the things that we do throughout the rest of the year in chemistry. To be able to do math and calculations with chemical reactions, we need to be able to balance our chemical equations. So good luck and get balancing.